Hi, everyone. Today, I'll introduce a series of nodes for working with arrays. The series covers operations such as inserting, filtering, removing, sorting, retrieving an item, and getting the array length. You can find all of these nodes in the data category. I've already created them, so I won't add each one again. Let's begin with build array. Build array lets you manually create an array. You can enter fixed values, which can also be treated as the array's initial values. For this example, I'll add 3 string values, 1, 2, and 3. The array now contains 3 array items. Each item is a string containing 1, 2, or 3. Save the node, then run the flow. After it runs, open the latest output from build array. Items contains the 3 strings 1, 2, and 3, and length is 3. The next node is getLength, which retrieves the length of an array. Run the flow again. Its latest output reports length 3 and type array. Next, let's look at append array. First, inspect its parameter configuration. Append array needs a source node. Select build array as the source and items as data to use. Append the string value 4, then save the node. Append array copies the array produced by another node. The important point is that it makes a copy. It does not modify the source array. It changes its own local copy by adding or removing items, then outputs the result again. Connect the nodes. Build array still contains 1, 2, and 3. Append array copies those values and adds 4, so its result should be 1, 2, 3, and 4. The original build array output should remain 1, 2, and 3. Keep these 2 results separate. Run the flow and inspect Build Array first. Build Array still outputs 1, 2, and 3. Append Array's latest input is 1, 2, and 3 from Build Array. Its output is 1, 2, 3, and 4, with a length of 4. Now, let's try Insert Array Item. It also needs a source node, so we'll use Build Array again. Next, choose the insertion position with index. Set index to 1, which means the second item, because array indexes start at 0. Insert the string value 4. Then save the node. Run the flow and inspect the output. The output becomes 1, 4, 2, and 3. The value 1 is at index 0, and the inserted value 4 is at index 1. Because 4 was inserted at index 1, the following items move back 1 position. Build Array itself is still unchanged. Insert Array Item also copies the source data, modifies the local copy, and then outputs it. This keeps the data used by these array nodes isolated from one another. Next is Remove Array Item. The current input from Insert Array Item is 1, 4, 2, and 3. We don't want 4 in this sequence, so we want to return to 1, 2, and 3. Select Insert Array Item as the source and set index to 1. Connect the node and run the flow. The latest input is 1, 4, 2, and 3, and index 1 is the position to remove. That position contains 4, so the latest item's output becomes 1, 2, and 3. The node also reports the removed value and whether the selected index exists. Next is Get Array Item. We've used this node many times before. It retrieves one item from an array. Use the output from removeArrayItem as the source. Keep index at 0 to retrieve the first item. Because the source contains 1, 2, and 3, the expected value is 1. Save the node and run the flow. The latest output shows exists true and index 0. Length is 3, and the retrieved value is 1. Let's continue with the contains node. Contains can check either text or an array. Select Build Array as the source and Items as the data. First, check whether the array contains the value 4. Connect the node and run the flow. Found is false, because build array only contains 1, 2, and 3. Now change the source to insert array item, whose output includes 4. Run the flow again. Found is now true because the input array contains the value 4. That is how contains works with an array. Next, let's look at the filter data node. It filters array items according to conditions that you define. Choose the source node that supplies the array. Here, use build array and its items output. Then add a filter rule in the configuration. The $sign represents the current array item. For example, when the current item is 1, the $sign represents that value 1. If an array item is an object, use a specific field name instead. We'll test that shortly. For now, use the $sign because these array items are simple strings. Comparison can be equal or one of the many other supported operators. Compare with source may be a fixed value or a value from another node. For this demonstration, use a fixed value. Build array contains 1, 2, and 3. Set the condition to current item equal 4. This means any item equal to 4 should be included in the filtered result. Run the flow. Since no item equals 4, the output is an empty array. Now use the same array of 1, 2, and 3 for a numeric comparison. Change comparison to greater than and compare each item with 1. The expected filtered array contains 2 and 3. After the flow runs, build array outputs 1, 2, and 3, while filter data outputs 2 and 3. Now add another item containing the string hello. Run the same greater than condition again. The node turns red because an error occurred. The error explains that greater than requires a numeric value. Because hello is a string, it cannot be used with that numeric comparison. Instead, change the condition to starts with and compare with the letter H. Run the flow again. This time, it succeeds. The output array contains hello because it begins with H and matches the condition. That covers simple array items. Next, let's configure filtering when each array item is an object. Now let's filter an array whose items are objects. An API request node retrieves an array of users from a sample API. Run it once to see the array returned by the API. Because each item is an object, do not use the $sign placeholder. Enter a specific field name. For example, use the email field and filter for email addresses that start with an uppercase A. You can also filter by fields such as phone number, user address, or username. For this test, use email starts with A. The sample API may return different data each time. This run happens to contain one matching result. The API returned about 10 users, and filter data kept the user whose email begins with A. This is how to configure filter data when each array item is an object. There are many other comparison operators available, so you can try them as needed. Now let's look at another node, sort data. It also requires a source node. First, use the API request result and sort by email in ascending order. Run the flow. This dataset is a little too large to make the order easy to see. So, create a smaller array to demonstrate the result more clearly. The new array contains 3 strings: hello, Lai, and chai. Because these array items are simple strings, use the $ as the field to sort. Select Build Array as the source node. Keep the direction ascending. Save and run the flow. Ascending order places chai first, hello second, and lai third, based on their first letters. The original order was hello, lai, and chai. The sorted order is chai, hello, and lai. Change the direction to descending to reverse the order. The result becomes lai, hello, and chai. That completes the introduction to this series of array nodes. Thanks, everyone.